Hi, this is Brendan Baines, the Math Department at Lipscomb University, here to talk with you today about systems of linear inequalities. In this presentation, you'll learn how to solve systems of linear inequalities by graphing. A system of linear inequalities is just like a system of equations in that we are looking for ordered pair solutions that are common to all inequalities. However, ordered pair solutions of inequalities are a bit different than ordered pair solutions to equations. Consider the single inequality y is greater than 3x plus 1. The ordered pair 1, 12 is a solution to this inequality, as well as the ordered pair 4, 18, as well as the ordered pair negative 100, 1. And in fact, we could keep on listing ordered pair solutions all semester long. What we would find as we plotted those ordered pair solutions is that some of them would follow along the line, but not actually on the line, like y equals 3x plus 1, but they would also be scattered all over the xy plane. And so not only are there an infinite number of solutions to an inequality, but they also follow less of a trend than do solutions to equations. For this reason, when we solve an inequality or a system of inequalities, we're going to graph the inequalities. And for us, we're going to use Wolfram Alpha or our TI 83, 84 graphing calculators to do that. When we graph an inequality, we have to shade where all of the solutions are. And so here, this purple area represents where all the solutions to y is greater than 3x plus 1, where all of those solutions are. Technically, the ordered pairs that follow along the line y equals 3x plus 1 would not be included as solutions to this inequality, because this inequality only wants y values greater than 3x plus 1, and all of these y values are equal to 3x plus 1. So again, when we want to solve an inequality or a system of inequalities, we're going to look at the shaded part of the graph. That's where all of our ordered pair solutions are. When graphing systems of linear inequalities, we shade only where the solutions overlap. And again, we'll use Wolfram Alpha to do this. And Wolfram Alpha does a nice thing of displaying only the overlap. And so we actually will not even have to consider where the shading overlaps. We will not have to do that by hand. We can use Wolfram Alpha. Here's an example. Suppose we want to solve the system of inequalities formed by y is greater than 3x plus 1 and y is less than 3x minus 5. Going to wolframalpha.com and typing the command graph y is greater than 3x plus 1 and y is less than 3x minus 5, then hitting enter will provide you with the following graph. And we see here that this parallelogram shape represents the solutions to this system of inequalities on the given viewing window here. Technically, these solutions would continue if we extended our y-axis and it up or down, we would see more of this shading. So that is simply the solution for our viewing window. Let's consider another example. We want to solve the system of inequalities formed by y is greater than 0, x is greater than 0. Those first two inequalities simply indicate that our values of x and y are going to have to be positive. That indicates that we're going to have to stay in the first quadrant where x's and y's are positive. A third inequality, y is greater than 2x greater than or equal to 2x plus 1. And the fourth inequality in our system of inequalities, y is less than or equal to negative 4x plus 13. Again, we'll type this into Wolfram Alpha, and it will produce the graph of the solution to this system. One nice thing about Wolfram Alpha is it allows you to type using everyday language, and it often will interpret what you're saying. And so when I went to Wolfram Alpha, I typed in the following command: y is greater than 0, x is greater than 0, y greater than or equal to 2x plus 1, and y less than or equal to negative 4x plus 13. So that is, instead of using the inequality symbol for greater than or equal to and less than or equal to, I simply wrote the words, and Wolfram Alpha knew what those words were indicating. So we see our solution to this system of inequalities is this triangular region. Any ordered pair falling within this region will satisfy all of these inequalities.